Let us solve this problem. A SOSE scholar who plays the guitar as his hobby has a Clash of Clans account he has been maintaining since his last date with a nerdy management engineering student, or introvert. His account has stored such a great amount of elixir that the game could not count his kingdom total elixir. All he knows is that when he stores them in jars that can contain 6,761 elixirs, he would have 42,069 elixirs remaining. This scholar is constantly in the first honors, has strong arms, listens to indie OPM and beabadobee, and does not care how much elixir he currently has. While chatting with a third-year student from University of the Philippines, Diliman, he absentmindedly asks whether the total number of elixirs can be a perfect square. Unsurprisingly, as expected, this cat provides the correct answer in 1 minute, and this Atenista spends 40 minutes verifying her answer. The question is now, how did this random Iska from Reddit arrive at her answer? So this question concerns elementary number theory, specifically quadratic residues. If m is a positive integer, we say that an integer a is a quadratic residue of m if a and m has no common factor, and that the congruence x squared is congruent to a modulo m has a solution. If this congruence has no solution, then we can say that a is a quadratic non-residue of m. There is a way we can find whether a is a quadratic residue of m or otherwise through this thing called the Legendre symbol. The Legendre symbol of a and p, where p is an odd prime and a does not divide p. Since if a divides p, then we are done. The Legendre symbol of a and p is 1 if a is a quadratic residue of p and negative 1 is otherwise. There are some ways we can identify the value of the Legendre symbol, which is through a theorem called the Euler's criterion, which will be used as a basis for some of the properties of the Legendre symbol. Now, the Euler's criterion says that let p be an odd prime where a is an integer such that p does not divide a. Then, the Legendre symbol of a and p is congruent to this expression modulo p. You can prove this to some of the theorems in any elementary number theory book by using Euler's criterion and some of the basic definitions of quadratic residues. We can now have some of the properties of the Legendre symbol. Firstly, if a is congruent to b modulo p, then the Legendre symbol of a and p is equal to b and p. So in lay terms, if they have the same remainder when divided by p for a and b, then we can say that the Legendre symbol is in a way equal. And the second one is, in lay terms, we can factor out ab. So when we have a number, let's say n, Legendre symbol of n and p, we can provide the prime factorization of n and then factor out the Legendre symbol so we can have our computation easier. And lastly, which is really convenient to use, the Legendre symbol of a squared and p is 1. And now we pay our attention to the problem. We find the Legendre symbol of 42069 and 6761. The first thing you notice is you can show either manually or number theory that 42,069 is 1,503 modulo 6,761. Take note that 6,761 is a prime. Now, the Legendre symbol of 1503 and 6761. We can take note of the prime factorization of 1503, which is 9 times 167. Using the previous property discussed, the Legendre symbol of 3 squared and 6761 is 1. And then we have one term remaining left. But then we may use one theorem which actually uses the Gauss lemma, although we will leave it for later. We will use the law of quadratic reciprocity for one of the properties that will be used here. So basically it says that we can flip the p's and q's, where p and q are odd primes. So here, the Legendre symbol of p and q is equal to the Legendre symbol of q and p if P is congruent to 1 modulo 4 or Q is congruent to 1 modulo 4 or both. And when you flip the Legendre symbol, you have to provide the negative 1. Formally, Legendre symbol of P and Q is equal to negative 1 times Legendre symbol of Q and P if both P and Q are congruent to 3 modulo 4. Basically, if you divide both P and Q by 4, both should have a remainder of 3 for Legendre symbol of P and Q to be the negative of Legendre symbol of Q and P. And now, here, take note that 167 is a prime, and 167 is 3 modulo 4 or negative 1 modulo 4. But 6761 is congruent to 1 modulo 4. So we can just swap them as is without providing the negative 1. Simplify this again, Legendre symbol of 6761 over 167, we will know that 6761 is congruent to 81 modulo 167. And we are sure that 81 is a perfect square. So the Legendre symbol of 42,069 and 6,761 is 1. Therefore, we can express the total number of elixirs as a perfect square.